Water. It's something we encounter every day in our lives, whether it's the glass you drink, the rain falling outside, or the oceans stretching to the horizon. But what if I told you that water is not just a simple substance? What if water is a living, dynamic system that stores information, sends signals, and supports the cells in your body? Today, we're diving deep into the mysteries of water, not as a passive liquid, but as a complex, intelligent system.
Hi everyone, welcome back to the channel. If you've ever wondered why water is so special, or how it can influence biological processes in such profound ways, you're in for a treat. In this video, we're going to take a deep dive into water as a system, how it stores data, transmits signals, and supports the cells it touches. Get ready to think about water in a whole new way. To start, let's break down water's basic structure. Water, in its simplest form, is a molecule made up of two hydrogen atoms bonded to one oxygen atom, H2O. But even at this fundamental level, water is unique. The way its molecules interact is what makes it so versatile.
Water is a polar molecule, which means it has a positive charge on one end and a negative charge on the other. This gives water some very special properties, like its ability to dissolve a wide variety of substances, making it an excellent solvent. This polarity also allows water molecules to form hydrogen bonds with each other, making water cohesive and giving it a high surface tension.
But water's molecular structure is just the beginning. This polarity and ability to bond make water much more than just a simple liquid. It creates an environment where water molecules can communicate with each other and respond to changes in their surroundings. 1. Electromagnetic fields, altering water's structure. Water's response to energy doesn't stop with temperature. In fact, water can also change its structure in response to electromagnetic fields, such as those produced by light, radio waves, or even the electromagnetic fields generated by living organisms. A. Water and light, photons, changing water's structure. One of the most intriguing ways that water's structure can be altered is through exposure to light, particularly to specific wavelengths of light, or photons. Research has shown that when light of certain frequencies hits water, it can cause the water molecules to oscillate or vibrate at a higher frequency. This vibration can rearrange the structure of the water, potentially forming more ordered, crystalline-like structures, especially in low-energy or cold water. This is why sunlight can have a profound impact on water quality in natural environments. The energy from sunlight can change the water's molecular structure, increasing the potential for interactions between water and other substances. In some cases, light exposure is said to promote the formation of clusters of water molecules, which are more organized than the random arrangement typically seen in liquid water. These clustered formations are often cited in alternative medicine and water-based therapies, where it's suggested that water, once energized by light or sound, can have healing properties. B. Electromagnetic fields. Can water remember information? Further studies have shown that electromagnetic fields, whether from external devices like cell phones, computers, or even magnetic fields, can influence water's molecular arrangement. Research conducted by Dr. Luc Montagnier and his team demonstrated that when water is exposed to electromagnetic signals associated with DNA or other molecular structures, it can remember or retain this information even after the source is removed. This suggests that water is sensitive to subtle energy fields, and that its molecular structure can shift in response to such influences. For example, Montagnier's controversial experiments showed that water exposed to low-frequency electromagnetic waves emitted by DNA sequences could retain those frequencies and continue to emit them long after the DNA was removed from the water. This phenomenon suggests that water may not only store and transmit information in the form of molecular structure, but also through energetic vibrations. 1. Sound. Vibrational influence on water's structure. Another form of energy that can influence water's structure is sound. Water, as a liquid, is highly sensitive to vibrations, and sound waves can induce dramatic changes in water's behavior and structure. A. The power of sound waves, resonance, and structure. The most notable demonstration of sound's effect on water was by Dr. Masaru Emoto, a Japanese researcher who claimed that water could respond to the energetic vibrations of sound. In his experiments, Emoto exposed water to different types of music, speech, and even thoughts, and then froze the water to observe the crystal formations. According to Emoto, positive vibrations, such as classical music or kind words, resulted in water forming symmetrical, beautiful crystal structures, while negative vibrations, such as heavy metal music or harsh words, led to malformed, chaotic structures. While the scientific validity of Emoto's claims remains contested, the idea that sound vibrations could influence the molecular arrangement of water is supported by basic principles of physics. Sound waves are essentially pressure waves that cause particles, in this case water molecules, to vibrate. At certain frequencies, these vibrations can lead to a phenomenon called resonance, which can cause the molecules to align or organize in specific ways, potentially forming patterns or clusters. B. Vibrational healing and water. In alternative medicine, sound therapy is often used with water to facilitate healing. Techniques such as binaural beats, singing bowls, and other vibrational therapies rely on sound to alter the energy within water. Proponents believe that by exposing water to healing frequencies, the water structure can become more harmonious, positively influencing the body's water systems. Now, let's dive into a more controversial and fascinating topic: water as a living system. Scientists have long studied water's role in supporting life, but recent theories suggest that water is much more than just a medium for life. It might actually store and transfer information.
Water is often described as having memory. That is, it can store information based on its interactions with other substances. You've probably heard of homeopathy, where water is said to remember the molecules it once came into contact with. While this is still a debated topic in mainstream science, recent studies show that water does, in fact, have some interesting properties that suggest it can retain information in subtle ways.
In studies, when water is exposed to various stimuli, such as electromagnetic fields or vibrations, it can form structured patterns. Some researchers believe these patterns could represent a form of information storage. Think of water as a kind of dynamic memory system, similar to how a computer stores data, but in a biological and fluidic way.
These patterns could potentially serve as a medium for transferring information within organisms. It's not just about the physical properties of water, but also how water interacts with its environment to relay data across different systems, whether it's the human body, plant cells, or even water's behavior in ecosystems.
Water doesn't just store information. It also plays a crucial role in transmitting signals within the body. Every time your heart beats, every time your brain fires a thought, water is there. It's a vital medium for signal transmission in biological systems.
At the cellular level, water is integral to how signals are passed. It acts as a carrier for ions, which are essential for electrical signaling. In the nervous system, for instance, water molecules help transport neurotransmitters from one nerve cell to another, enabling communication between cells.
Water is also involved in the transport of nutrients and waste products. In the blood, water carries oxygen, hormones, and other essential substances throughout the body. In fact, without water, cellular communication and even the simplest biological processes wouldn't be possible.
Think about it. Water is the silent carrier of essential signals. It doesn't just hold molecules together, it supports the infrastructure of life, helping cells send and receive messages that keep us alive and functioning.
Now we enter some truly mind-bending territory: water and its relationship to quantum mechanics. Water isn't just a simple molecule. It may play a role in quantum biological processes. Researchers are beginning to ask whether water behaves like a quantum system, influencing everything from the energy we get from food to how our brains process thoughts.
Quantum mechanics is the study of particles at the smallest scales, where the usual rules of physics no longer apply. And here's where it gets wild. Some researchers believe that water could play a role in quantum processes that support life. For example, water molecules might help facilitate quantum tunneling, a process where particles can pass through barriers they normally shouldn't be able to.
At the quantum level, water's ability to form and break hydrogen bonds quickly could make it a perfect candidate for enabling quantum coherence in biological systems. This means that water may be involved in the processes that allow organisms to tap into energy from the environment at a deeper level than we currently understand. Title: Quantum Processes: Enhancing Biological Systems and Life Itself. Introduction. Imagine a world where biology and quantum physics intersect, where the laws of the universe at the microscopic level influence everything from how cells communicate to how plants capture energy. Quantum processes, often thought of as something distant and abstract, are actually essential to life as we know it. They play a crucial role in biological systems, helping our bodies function at a level beyond what we could ever see or understand without diving into the quantum realm. In today's video, we'll explore the fascinating connection between quantum physics and biology, and how these quantum processes improve biological systems, from plants to animals, and even the cells in our own bodies. You might just be surprised at how much quantum physics is involved in keeping us alive and healthy. Section 1. What is quantum biology? Let's begin by understanding what we mean when we talk about quantum biology. In simplest terms, quantum biology is the study of how quantum mechanical processes influence biological systems. You might be familiar with quantum physics in relation to technology. Think of quantum computers, for example. But what if these same quantum principles are playing a role in the biology of life itself? At the quantum level, particles like electrons don't behave in predictable ways like classical objects. Instead, they follow principles of quantum mechanics: superposition, entanglement, tunneling, and coherence. While these may sound like complex terms, their effects can be seen in how biological processes work on a cellular level. From the way enzymes catalyze reactions to how plants convert sunlight into energy, quantum biology explains how life takes advantage of these quantum effects. Section 2. Photosynthesis and quantum efficiency. Host. Let's start with one of the most well-known examples of quantum biology: photosynthesis. This is the process by which plants convert sunlight into chemical energy, essentially how plants fuel their growth. Key. While the basics of photosynthesis might seem straightforward, plants absorb light, produce energy. The underlying mechanism is more complex than we originally thought. In fact, quantum coherence plays a vital role in making this process incredibly efficient. In photosynthesis, light energy is absorbed by chlorophyll molecules in plant cells. These molecules excite electrons, setting them into motion. Now here's the key. Instead of the electrons following a simple linear path, they use quantum coherence to exist in multiple states simultaneously, exploring many potential pathways. This quantum behavior allows them to find the most efficient route to transfer energy. This process helps the plant maximize its energy conversion and reduces the loss of energy during the transfer. Thanks to quantum mechanics, photosynthesis is much more efficient than it would be in a classical, non-quantum world. In other words, quantum processes help plants get the most out of sunlight, and this efficiency is passed on to us. Plants are the foundation of the food chain, and they rely on quantum processes to thrive. Section 3. Quantum tunneling in enzyme reactions. Host. Moving on to another fascinating quantum process at play in biology: Quantum tunneling in enzyme reactions. Enzymes are proteins that speed up chemical reactions in our bodies, which is crucial for everything from digestion to metabolism. In classical physics, molecules need a certain amount of energy to overcome a barrier before a reaction can take place. Think of it like a ball needing enough force to roll over a hill. But in the quantum world, particles like electrons can tunnel through barriers they wouldn't normally be able to cross. This is called quantum tunneling. When an enzyme catalyzes a reaction, quantum tunneling allows the reacting molecules to bypass the energy barrier, speeding up the process. This is incredibly important for our metabolism because it means that our biochemical reactions happen much faster and with less energy input. For example, in the process of cellular respiration, quantum tunneling enables the transfer of electrons in the electron transport chain, which helps generate energy in the form of ATP, the molecule that powers all cellular activities. So, the next time you think about metabolism, remember that quantum tunneling may be helping to accelerate these processes and make them more efficient. It's one of the unsung heroes of energy production in your body. Section 4. DNA repair and quantum coherence. Host. Now let's talk about one of the most essential processes in maintaining the integrity of life: DNA repair. Our DNA is constantly being damaged by UV radiation, environmental toxins, and other stressors. Fortunately, our cells have intricate systems to fix this damage and maintain our genetic code. When our DNA gets damaged, special repair enzymes rush in to fix the problem. Here's where quantum biology gets even more interesting. Recent research suggests that quantum coherence might help synchronize the actions of these repair enzymes, making the repair process faster and more accurate. By operating in a quantum state, the enzymes involved in DNA repair may be able to coordinate their actions more effectively, improving the efficiency of the entire repair process. This quantum synchronization helps ensure that the genetic material in our cells is preserved and that we don't accumulate mutations, which could lead to diseases like cancer. Section 5. Quantum processes in brain function. Host. Let's shift gears and talk about the brain, the most complex biological system we know of. The brain's function relies on a series of electrochemical signals that travel between neurons, allowing us to think, remember, and interact with the world around us. But what if quantum mechanics plays a role in these brain functions as well? Some scientists believe that quantum processes, such as quantum entanglement and superposition, might be involved in how our neurons communicate. In particular, quantum coherence could help our brain cells transmit signals more quickly and efficiently by allowing multiple pathways to be explored at once. Imagine it like this. Your brain needs to solve a problem. Instead of taking a single path to the solution, quantum processes may allow neurons to explore many different potential solutions simultaneously, speeding up decision-making and improving cognitive abilities. This kind of quantum advantage may also help explain how our brain can process vast amounts of information in such a short amount of time, all while maintaining clarity and precision in our thoughts. Section 6. Quantum processes in evolution. Host. Finally, let's explore how quantum processes may have played a role in evolution. From the simplest organisms to complex multicellular life, quantum mechanics might have been the driving force behind some of the most crucial steps in biological development. Host. Voiceover. For instance, quantum effects like quantum tunneling might have influenced the evolution of photosynthetic systems in plants. Similarly, quantum coherence could have helped early life forms harness energy more efficiently, giving them an evolutionary advantage in survival. Quantum processes may have been a key factor in shaping the development of life itself, enabling organisms to thrive in ways that classical processes alone couldn't explain. Conclusion: the quantum future of biology. Host. As we've seen today, quantum processes are not just the stuff of physics labs and science fiction. They are deeply embedded in the very fabric of biological systems. From photosynthesis to enzyme reactions, DNA repair, and even brain function, quantum biology is shaping the way life functions at every level. Host. Cut to host. Understanding how quantum processes improve biological systems could lead to groundbreaking advancements in medicine, biotechnology, and health optimization. The next frontier in biology is understanding these quantum processes and harnessing them to enhance life, just as nature has done for millions of years. So, the next time you marvel at the complexity of life, remember that there's a hidden quantum world behind it all, making it possible for us to live, grow, and evolve. Thanks for watching, and don't forget to like and subscribe. Title: The Dark Side of Quantum Dots: How Man-Made Nanoparticles Are Threatening Our Environment and DNA. Introduction, narrator, voiceover. At the cutting edge of technology, quantum dots are being hailed as a breakthrough in science, from revolutionizing electronics to advancing medical imaging. But hidden behind their promising applications lies a darker side. Quantum dots are tiny nanoparticles that are increasingly being used in consumer products, technology, and even medicine. But what happens when these man-made nanoparticles find their way into the air, soil, and water, becoming part of our environment? Host. In today's video, we're going to explore how quantum dots, while promising many benefits, are becoming a growing environmental and health risk. These nanoparticles are infiltrating our ecosystem, impacting everything from plants to animals, and even damaging human DNA. Let's dive into the dangers of quantum dots and what they could mean for the future of our planet. Section 1. What are quantum dots? Host. Before we dive into the problems, let's first understand what quantum dots actually are. Quantum dots are extremely tiny semiconductor particles, typically only a few nanometers in size, about 10,000 times smaller than the width of a human hair. Host. Voiceover. These nanoparticles have unique optical and electronic properties that make them incredibly useful in a wide range of applications, from displays and solar cells to biomedical imaging and drug delivery systems. They're often made from toxic elements like cadmium, lead, or selenium, which contribute to their unique properties, but also make them hazardous to living organisms. Host. Cut to host. While these applications can improve technology and medicine, the problem arises when these quantum dots are released into the environment. Their tiny size allows them to easily become airborne or enter waterways, spreading across ecosystems where they cause significant harm. Section 2. Quantum dots in the air: How they enter the environment. Host. Quantum dots don't just stay in controlled environments like labs or factories. They're increasingly used in everyday products like LED screens, solar panels, and cosmetics. During the manufacturing, disposal, or wear and tear of these products, quantum dots can break down into nanoparticles that become airborne or leach into the soil and water. Host. Voiceover. Once released, these particles become part of the air we breathe, the water we drink, and the soil that supports plant life. Due to their tiny size and high surface area, quantum dots can travel long distances and infiltrate even the most remote ecosystems. Host. Cut to host. The big issue here is that these nanoparticles are not easily contained. They are too small to be filtered by traditional air filtration systems, and they don't break down quickly in the environment. This means that they persist long after they are released, accumulating in the soil, water, and atmosphere. Section 3. Impact on plants and the ecosystem. Host. One of the first places quantum dots are having a direct impact is on plants. Plants are the foundation of most ecosystems, absorbing nutrients from the soil, providing oxygen, and acting as a source of food for countless species. But when quantum dots contaminate the environment, they can have detrimental effects on plant life. Host. Voiceover. Studies have shown that when plants come into contact with quantum dots, whether through the air, water, or soil, the nanoparticles can be absorbed into their root systems. This can interfere with the plant's normal biological functions, damaging their cell membranes and chlorophyll, which is essential for photosynthesis. Host. Cut to host. Quantum dots can cause plants to grow more slowly, produce fewer seeds, or even die off entirely. This disrupts entire ecosystems and reduces the ability of plants to support the animals that rely on them for food. It's a domino effect, with cascading consequences for biodiversity. Section 4. Harmful effects on animals and the food chain. Host. Next, let's talk about how quantum dots affect animals, particularly those higher up in the food chain. Animals, especially aquatic life and insects, are often exposed to quantum dots through water and soil. Host. Voiceover. When animals ingest plants contaminated with quantum dots, the nanoparticles enter their digestive systems. These particles can accumulate in tissues and organs, where they may cause severe damage. In fish, for example, quantum dots can affect their gills and liver, disrupting their ability to breathe, metabolize food, and reproduce. Similarly, insects like bees and butterflies that consume contaminated plants or water may experience neurological and reproductive problems. Host. Cut to host. As these toxic nanoparticles move up the food chain, they accumulate in larger animals, including humans, and cause greater harm. The persistent nature of quantum dots means they can bioaccumulate, building up in the tissues of organisms over time, leading to long-term health consequences. Section 5. Quantum dots and human DNA damage. Host. Perhaps the most concerning impact of quantum dots is their potential to damage human DNA. Given that quantum dots are often made from toxic elements like cadmium and lead, they pose a serious risk to human health. Host. Voiceover. Once inside the body, whether through inhalation, ingestion, or skin contact, quantum dots can be absorbed into cells, where they interact with DNA. Studies have shown that cadmium-based quantum dots can cause genetic mutations and oxidative stress, both of which are linked to cancer and other diseases. Host. Cut to host. DNA damage is particularly concerning because it can lead to mutations, affecting not just the individual, but also future generations. This can increase the risk of chronic diseases like cancer, neurological disorders, and reproductive issues. The toxic effects of quantum dots are compounded by their ability to persist in the body and bioaccumulate over time. Section 6. Environmental persistence and long-term risks. Host. One of the major challenges with quantum dots is that they don't break down easily in the environment or in the body. Unlike larger pollutants that may eventually decompose or dissipate, quantum dots are highly stable due to their engineered properties. Host. Voiceover. The persistence of quantum dots in the environment means that they can continue to spread and accumulate for years, if not decades. As they move through ecosystems, they can have long-lasting effects on soil health, water quality, and biodiversity. Host. Cut to host. At the same time, the ongoing exposure to quantum dots through our air, water, and food sources increases the likelihood that humans will face health problems, particularly those who are most vulnerable, like children, pregnant women, and the elderly. Section 7. What can be done? Host. So, what can we do to protect ourselves and our planet from the dangers of quantum dots? The first step is to understand the risks. Scientists and governments need to invest in research to better understand the long-term effects of quantum dots on both human health and the environment. Host. Voiceover. Stronger regulations are needed around the manufacturing and disposal of products containing quantum dots, especially when they contain toxic materials like cadmium and lead. Additionally, industries should prioritize the development of safer alternatives to quantum dots that don't pose such serious environmental and health risks. Host. Cut to host. On an individual level, we can advocate for more sustainable technologies and ensure that products containing quantum dots are properly regulated and disposed of. Supporting companies that prioritize safety, sustainability, and eco-friendly alternatives can make a difference. Conclusion. Host. While quantum dots hold enormous promise for many technological applications, their environmental and health risks cannot be ignored. As these nanoparticles continue to spread into our ecosystems, they threaten plants, animals, and humans alike, damaging DNA, disrupting biological systems, and causing long-term harm to the environment. Host. Cut to host. It's crucial that we address these risks now before the damage becomes irreversible. We need to prioritize research, regulation, and the development of safer alternatives to ensure that quantum technology doesn't come at the cost of our planet's future. Thanks for watching, and don't forget to like, share, and subscribe for more in-depth discussions on how technology affects our world. One of the most controversial and fascinating ideas surrounding water is the concept of water memory. This theory suggests that water can remember the substances it has been in contact with, even after those substances are no longer present. It's a concept that has intrigued researchers for decades.
Jacques Benveniste's groundbreaking work in the 1980s suggested that water could retain a memory of substances that had once been dissolved in it, even after they had been removed. While his results were controversial, his research sparked intense interest in the potential of water to act as a form of information storage.
But the idea of water memory didn't end with Benveniste. One of the most significant and recent contributions to this theory came from Luc Montagnier, the Nobel Prize-winning scientist known for his discovery of HIV. In 2009, Montagnier and his team conducted a set of experiments that reignited the debate about water's ability to store information.
In Montagnier's experiments, he demonstrated that water could remember the DNA it had once been in contact with. His team used a technique where they exposed water to low-frequency electromagnetic signals, which were emitted by specific DNA sequences. Astonishingly, Montagnier's research showed that these signals could still be detected even after the DNA was removed from the water.
Montagnier proposed that water could retain the electromagnetic signature of the DNA, and that these electromagnetic waves could be used to transmit information. Essentially, water could remember the molecular structure of the DNA it had been in contact with and retain that information long after the physical molecules had disappeared.
His findings were controversial and met with skepticism from many in the scientific community. Critics questioned the methodology and the implications of such results. However, Montagnier's work has had a profound impact, opening new doors for understanding water's potential role in biological information processing.
Montagnier's experiments go beyond the typical understanding of water as just a solvent or medium. If water can indeed store and transmit information in this way, it suggests that water could function as more than just a passive element in biology. It could be an active participant in the transfer of information between cells and across systems, almost like a living database that holds data on the molecular and energetic level. Types of toxic contaminants in water. Water toxicity can arise from several sources and types of contaminants, each with its own risks and mechanisms of harm. 1. Heavy metals. Heavy metals are inorganic compounds that can accumulate in the body over time and lead to toxicity. Common heavy metals found in water include lead, Pb, often leached from old pipes, plumbing fixtures, or industrial activities. Lead is highly toxic, especially for children, and can cause neurological damage, developmental issues, and kidney problems. The EPA, U.S. Environmental Protection Agency, has set a limit of 0 ppb, parts per billion, for lead in drinking water, though any exposure is considered harmful. Mercury, Hg, a neurotoxin that can cause damage to the nervous system, kidneys, and heart. Mercury often enters water bodies from industrial waste, mining activities, or atmospheric deposition from burning fossil fuels. Mercury is particularly toxic to fish and can bioaccumulate in the food chain. Arsenic, AS, a carcinogen found in well water or regions with high natural levels of arsenic in the soil. Chronic exposure to arsenic can lead to skin cancer, lung cancer, and damage to the liver and kidneys. Cadmium, CD, typically found in water due to industrial pollution, mining activities, or battery disposal. It can cause kidney damage, bone disease, and can be carcinogenic. Chromium, Cr, often introduced into water from industrial waste, such as chrome plating or leather tanning. Hexavalent chromium, CR-FIX, is highly toxic and can cause lung cancer, liver damage, and other health issues. 1. Pesticides and herbicides. Agricultural runoff is a major source of pesticide contamination in water. Pesticides can be toxic to humans and wildlife and are often carcinogenic or cause endocrine disruption. Common examples include glyphosate, the active ingredient in many herbicides, which has been linked to cancer and other long-term health issues. Atrazine, a widely used herbicide that has been shown to disrupt endocrine function, particularly affecting fertility and hormonal balance. DDT. Although banned in many countries, DDT can still be found in some water bodies, especially in developing regions, and is associated with neurological damage and cancer. 1. Industrial chemicals. A wide variety of industrial chemicals can be toxic if they end up in drinking water, either as waste from manufacturing processes or as pollutants from industrial accidents. Examples include perfluorooctanoic acid, PFOA, and perfluorooctanosulfonic acid, PFOS. These chemicals, also known as PFAS, per- and polyfluoroalkyl substances, are used in the manufacture of non-stick coatings, firefighting foam, and water-resistant materials. They are persistent in the environment and can cause liver damage, thyroid problems, and immune system issues. Volatile organic compounds, VOCs, chemicals like benzene, toluene, xylene, and trichloroethylene, TCE, are commonly found in contaminated water. These compounds are carcinogenic, neurotoxic, and can cause liver and kidney damage. 1. Nitrate and nitrite contamination. Nitrates, NO3, and nitrites, NO2, are common contaminants in groundwater, primarily due to agricultural runoff, fertilizers, and manure. High concentrations of nitrates can cause methemoglobinemia, also known as blue baby syndrome, in infants, which impairs the ability of red blood cells to carry oxygen. Long-term exposure to nitrates is also associated with cancer of the digestive system. 1. Pharmaceuticals and personal care products, PPCPs. Trace amounts of pharmaceuticals and personal care products, e.g., antibiotics, hormones, pain relievers, and cosmetic ingredients, are often found in water due to wastewater discharge, improper disposal, and agricultural runoff. Some of these compounds can disrupt hormonal systems, contribute to antibiotic resistance, and have other adverse effects on human health. 2. Microbiological contaminants. Bacteria, harmful bacteria such as E. coli, Salmonella, Campylobacter, and Vibrio cholerae can contaminate water through fecal contamination. These bacteria can cause diarrhea, vomiting, fever, and other gastrointestinal illnesses. Viruses, waterborne viruses like norovirus and hepatitis. A can be transmitted through contaminated water. These can cause liver damage, gastroenteritis, and other serious conditions. Protozoa, Giardia and Cryptosporidium, are waterborne parasites that cause intestinal illnesses. They are often resistant to chlorine disinfection and can cause severe diarrhea and dehydration. Algal toxins, harmful algal blooms, HABs, in water can release toxins like microcystins, which can be toxic to both humans and animals, affecting the liver and kidneys. 1. Radionuclides. Certain regions have naturally occurring radioactive materials, like radon, uranium, and radium, that can contaminate groundwater. Long-term exposure to radionuclides can increase the risk of cancer and cause damage to internal organs. How to detect toxicity in water. Quality testing is essential for identifying toxic contaminants. There are several ways to detect toxicity. Water testing kits. Simple home water testing kits can measure common contaminants like lead, pH, chlorine, and nitrates. More comprehensive kits test for a wider range of substances. Certified laboratories. For more accurate and thorough testing, you can send water samples to certified laboratories for analysis. These labs can test for heavy metals, chemicals, bacteria, and other toxins. Indicators of contamination. Visible signs of contamination, like cloudy water, unusual odors, or a metallic taste, can sometimes suggest the presence of toxic substances. Health effects of toxic water contaminants. Exposure to toxic substances in water can have a wide range of short-term and long-term health effects, depending on the type of contaminant, the concentration, and the duration of exposure. Some common health effects include acute poisoning. High concentrations of toxic chemicals, e.g., arsenic, mercury, cyanide, can cause immediate poisoning symptoms, such as nausea, vomiting, diarrhea, dizziness, and even death. Cancer. Prolonged exposure to certain chemicals, e.g., arsenic, benzene, PFOA, and radiation, e.g., radon, can increase the risk of cancers, especially in the liver, lungs, and skin. Neurological damage. Heavy metals like lead and mercury, as well as certain industrial chemicals, can cause nervous system damage, leading to cognitive impairment, developmental issues, and behavioral changes. Hormonal disruption. Chemicals like pesticides, pharmaceuticals, and endocrine disruptors can interfere with the body's hormonal balance, potentially leading to fertility issues, birth defects, and other endocrine-related problems. Kidney and liver damage. Long-term exposure to certain chemicals like cadmium, nitrate, and arsenic can damage the kidneys and liver, leading to organ failure in extreme cases. Gastrointestinal issues. Pathogens in contaminated water, like bacteria, viruses, and protozoa, can cause diarrhea, vomiting, and dehydration, which can be particularly dangerous for young children and the elderly. So, what does this all mean for health and healing? If water can store and transfer information, then its role in the body takes on a whole new dimension. From alternative healing practices like hydrotherapy to sound healing, water has been used for centuries as a tool for restoring balance and energy.
Research on the energetic properties of water has shown that water is sensitive to frequencies, vibrations, and electromagnetic fields. In fact, therapies that use these principles, like sound therapy and crystal healing, may be tapping into water's unique ability to carry and transmit information.
Imagine water as an energetic conductor. As Montagnier's work suggests, water may not only transmit information through electromagnetic waves, but could also be deeply connected to the energy fields of living organisms. This could help explain why certain forms of alternative medicine, which use water or energy-based therapies, have been reported to have healing effects. Let's venture a bit further into the unknown. Could water play a role in quantum biology? Quantum mechanics, the science of particles at the smallest scale, deals with phenomena that can't be explained by classical physics. Some researchers now believe that water may be a crucial part of quantum biological processes.
In quantum mechanics, particles can sometimes pass through energy barriers, a phenomenon called quantum tunneling. Some scientists speculate that water could assist in this process, enabling biological systems to perform complex energy transfers in ways we don't yet fully understand.
Quantum processes may sound like science fiction, but they could be happening in your body right now. The complexity of biological systems like photosynthesis, or even the way our brains process thoughts, might be enhanced by water's unique quantum properties. It's possible that water is a mediator of quantum coherence in living organisms, allowing energy to be transferred more efficiently within cells. Could water's memory have practical applications in medicine or technology? 5. Water as a memory system, energy transfer and information. One of the most revolutionary ideas surrounding water's structure is its ability to store and transfer energy in the form of information. If water can change its structure based on energy, could it also function as a type of memory system? As discussed earlier, the idea that water can remember the substances it has been in contact with, whether through electromagnetic fields or molecular interactions, suggests that water is more than a simple liquid. It could act as an energetic memory system, holding on to patterns and frequencies long after the original source of energy is gone. This concept has far-reaching implications, from the idea of water being used in alternative healing practices to the potential for water as a medium for storing biological or even digital information. Just as crystals can store information in their atomic structure, water might have the ability to hold information on a molecular and energetic level. 1. Water's role in biological systems, energy, and structure in life. Water's ability to adapt and change its structure in response to energy is not just a curious feature, it is essential for life itself. Every process in biology, from cellular communication to energy transfer and photosynthesis, relies on the dynamic properties of water. Water is a key player in the transfer of information within living systems. In the human body, for instance, water helps transmit electrical signals in the nervous system, acts as a medium for molecular interactions, and carries vital nutrients and waste products. The ability of water to respond to energy, from the food we eat to the electromagnetic fields in our environment, means that it is not just a passive transport system, but an active participant in maintaining life.
While Montagnier's work has stirred excitement in some circles, it has also raised new questions. If water can store and transmit information, could we harness this ability for purposes beyond biology? Imagine using water as a medium for data storage, an entirely new way of storing and transferring information. It's a concept that could revolutionize fields like computing, bioengineering, and even communication.
But the challenges are immense. As fascinating as these findings are, they are still controversial, and much more research is needed to validate these ideas. Nonetheless, the potential is huge, and scientists around the world are working to uncover the true capabilities of water.
What happens? When the brain is dehydrated, dehydration affects the entire body, but its impact on the brain can be particularly profound. The brain is about 75% water, and it relies on hydration to function optimally. When the body is dehydrated, the brain's ability to perform various cognitive and physiological processes begins to decline. Even mild dehydration can lead to noticeable changes in mood, concentration, and mental clarity. Here's what happens when your brain doesn't get enough water. 1. Impaired cognitive function. The brain requires a constant supply of water to stay sharp. Dehydration can lead to difficulty with concentration, memory, and problem solving. You may experience reduced attention span. When dehydrated, your ability to focus on tasks can drop, and you might find it harder to maintain attention for extended periods. Memory issues. Dehydration can interfere with short-term memory, making it more difficult to remember names, facts, or ideas. Slower reaction times. Dehydration slows down the brain's processing speed, causing slower reflexes and longer decision-making times. Research shows that even mild dehydration, as little as 1 to 2% loss of body weight, can result in difficulty performing tasks that require attention and memory. 1. Mood and mental health disturbances. Water is essential for maintaining the chemical balance in the brain, including the production and regulation of neurotransmitters like serotonin and dopamine, which control mood, motivation, and emotional responses. When you are dehydrated, increased irritability. Dehydration can make you more easily frustrated or annoyed as the brain's neurotransmitter balance is affected. Anxiety and stress. Mild dehydration can trigger feelings of anxiety or stress. This happens because dehydration causes a spike in cortisol, the stress hormone levels, and an imbalance in hydration levels can disrupt the autonomic nervous system. Depression symptoms. Chronic dehydration has been linked to mood disorders such as depression. When the brain is deprived of water, it can lead to feelings of fatigue, sadness, or general emotional numbness. 1. Headaches and migraines. The brain is highly sensitive to changes in hydration levels. One of the most common symptoms of dehydration is a headache, which can range from mild to severe. Tension headaches. When you're dehydrated, the brain can temporarily shrink from fluid loss, leading to a painful tension headache. This can happen because the body tries to conserve water by pulling fluids from less vital organs. Migraines. Dehydration is also a common trigger for migraines, especially in people who are already prone to these types of headaches. Studies have shown that dehydration can be a key factor in the frequency and intensity of migraine attacks. In addition, dehydration reduces the brain's blood flow, which can contribute to headache and migraine pain. 1. Cognitive fatigue and lack of focus. Dehydration can significantly affect your energy levels. You may feel mentally drained and find it hard to keep up with daily tasks. Mental fatigue. When you're dehydrated, the brain works harder to process information. As a result, mental fatigue sets in faster, making it harder to think clearly and stay productive. Difficulty in decision-making. Dehydration can impair your ability to think critically and make decisions. This is due to reduced brain function, leading to slower information processing and an inability to weigh options effectively. 1. Reduced brain efficiency and processing speed. The brain uses a lot of energy to perform daily tasks. Water is essential for maintaining the brain's energy levels. Dehydration makes the brain work harder to perform cognitive tasks, reducing its efficiency. This results in lowered processing speed. Your brain may take longer to process information and make decisions. This delay can affect everything from driving to work, answering emails, or engaging in a conversation. Decreased mental clarity. Dehydration can lead to brain fog, where you feel mentally clouded or unclear. This makes it difficult to focus, think logically, or recall information on demand. 1. Disruption of neural activity and electrical impulses. Water is a key component of the body's electrical systems, including those that regulate brain activity. Neurons in the brain communicate via electrical signals, which depend on the balance of ions like sodium, potassium, and calcium. Impaired signal transmission. Dehydration can disrupt this balance, affecting how neurons fire and transmit information. This can cause sluggish mental performance and poor coordination between brain regions. Cognitive dissonance. When the brain isn't properly hydrated, the efficiency of these electrical signals drops, leading to a disconnect between different areas of cognitive function, e.g., difficulty thinking and feeling in sync. 1. Decreased alertness and increased fatigue. Water is a natural energy booster for the brain. Without sufficient hydration, brain function declines, leading to feelings of tiredness and sluggishness. Fatigue. Dehydration can cause general tiredness because your body has to work harder to maintain normal physiological functions. Mental fatigue also increases as your brain struggles to stay alert and active. Low energy. Without the proper amount of water, your brain lacks the necessary fluid to operate at full capacity. This makes you feel mentally drained and lethargic, even after a full night's rest. 1. Impaired sleep and quality of rest. Even mild dehydration can interfere with sleep patterns. Dehydration may disrupt sleep quality. Water plays a role in regulating the production of melatonin, the hormone responsible for sleep cycles. Dehydration can lead to disrupted sleep, making it harder to fall asleep or stay asleep. Increased nighttime thirst. If you're dehydrated during the day, it can cause you to wake up more often during the night to drink water, disrupting your sleep and making it harder to achieve deep, restful sleep. 1. Long-term effects of chronic dehydration on the brain. While mild dehydration may only cause temporary cognitive dysfunction, chronic dehydration can have lasting effects on brain health. Neurodegeneration. Some research suggests that prolonged dehydration may contribute to brain shrinkage, particularly in older adults. The brain needs adequate hydration to function properly, and without it, neurons can become damaged over time. Impaired learning and memory. Chronic dehydration can result in long-term deficits in memory and learning abilities. Since the brain depends on water to form new neural connections, consistent dehydration can slow down cognitive development and learning capacity. How much water does the brain need? The brain uses a large portion of the body's water. To stay hydrated and keep your brain functioning optimally, aim to drink plenty of water throughout the day. A good rule of thumb is to drink around 8 glasses, about 2 liters, of water per day. But this can vary based on your size, activity level, and environment. Signs of dehydration that you should watch out for include thirst, dry mouth and skin, fatigue, dark yellow urine, dizziness or confusion. If you notice any of these symptoms, it's time to hydrate. Aim to drink water regularly throughout the day and try to incorporate foods with high water content, like fruits and vegetables, into your diet as well. Conclusion: hydrate for a healthy brain. Your brain's performance depends heavily on proper hydration. Even mild dehydration can impair cognitive function, mood, and overall mental clarity. For optimal brain health, make sure to stay hydrated, especially during hot weather, physical exertion, or times of stress. By keeping your brain hydrated, you'll help improve focus, memory, mood, and cognitive abilities, allowing you to think, learn, and perform at your best.
So, after all we've explored today, what can we conclude about water? It's clear that water is not just a simple liquid. It's a complex system, one that stores and transmits information, supports life at the cellular level, and possibly even plays a role in the quantum processes that govern biology. It's a dynamic, living medium that is far more intricate than we ever realized. From the experiments of Luc Montagnier to the mysteries of water memory and quantum biology, we're just scratching the surface of what water can do. Water is, without a doubt, one of the most remarkable substances in the universe. And as we continue to study it, who knows what new discoveries we'll uncover about this life-sustaining, intelligent system. How the King Hydrogen Water Distillery works. 1. Water distillation, purification through distillation. Like traditional distillers, the King Hydrogen Water Distillery begins by purifying water through the distillation process. Distillation involves boiling the water to produce steam, which rises and leaves contaminants behind, such as minerals, heavy metals, chlorine, pesticides, and microorganisms. The steam is then condensed back into liquid water, leaving behind impurities, resulting in pure H2O. High purity. This distillation step ensures that the water is free from harmful chemicals, microorganisms, and solids, making it ultra-pure before hydrogen infusion. Potential benefits of King Hydrogen Water. 1. Antioxidant properties. Molecular hydrogen is a potent antioxidant that can help neutralize harmful free radicals in the body. Free radicals are unstable molecules that can cause oxidative stress, leading to cellular damage, inflammation, and various chronic diseases, including heart disease, diabetes, and neurodegenerative conditions like Parkinson's disease. 2. Anti-inflammatory effects. Some studies suggest that drinking hydrogen-rich water may have anti-inflammatory effects, which can be beneficial for individuals suffering from conditions like arthritis, joint pain, and chronic inflammation. 3. Improved hydration. Hydrogen-rich water may have enhanced hydration properties, as it has been suggested that molecular hydrogen can improve water's ability to penetrate cells and enhance cellular hydration. This may be particularly beneficial for athletes or those looking to stay better hydrated. 4. Cognitive health. The antioxidant properties of hydrogen-rich water might also benefit brain health. By reducing oxidative stress in the brain, hydrogen water may help improve cognitive function and potentially slow down neurodegenerative diseases like Alzheimer's and Parkinson's. 5. Improved skin health. Hydrogen-rich water's antioxidant effects may also benefit skin health by fighting free radicals that contribute to aging and skin damage. Drinking hydrogen-infused water may help maintain youthful skin by reducing wrinkles and enhancing skin elasticity. 6. Athletic performance and recovery athletes often use hydrogen-rich water to help reduce muscle fatigue, lactic acid buildup, and delayed onset muscle soreness, DOMS. The antioxidant properties of hydrogen may help reduce oxidative stress caused by intense physical exertion, improving recovery times. Conclusion: the King Hydrogen Water Distillery offers a cutting-edge solution for those interested in both purified water and the potential health benefits of molecular hydrogen. By combining the time-tested process of distillation with the modern addition of hydrogen infusion, the distillery creates water that is pure, antioxidant-rich, and potentially beneficial for overall health. Thanks for joining me on this deep dive into the incredible properties of water. If you enjoyed this video, be sure to hit the like button, subscribe to the channel, and share your thoughts in the comments below. Until next time, stay curious and keep exploring the mysteries of our world.